Okay, let's continue here. So they say throughout this chapter we are concerned with two things. One is experiments whose outcomes are not predictable with certainty in advance. So we're going to use this word experiment in a kind of a broad sense to mean like tossing a coin or flying a rocket to Mars. These will all be called experiments. So one thing is we're going to be concerned with experiments whose outcomes are not predictable with certainty in advance. And two, the outcomes themselves. So we're going to be concerned with the experiments. What kind of experiments? Experiments where the outcomes are not predictable with certainty in advance. And two, the outcomes themselves. The term experiment is used in a broad sense to mean the observation of any physical occurrence. So it's being very general about what they mean by experiment here. Okay, since we are interested in probabilities of events associated with these experiments, so we're interested in the probabilities of events associated with these experiments, it's necessary that the term event also be given a precise mathematical meaning. This is our objective in the remainder of this section. Okay, so one thing is I want to explain what this is, the sample space. So, you know, if I ask you what's the probability of getting a 5 when you toss a die, what's the probability of getting a 5? Everybody will say 1/6, but how do they do that? What happens in your brain when you say 1/6? So what happens is that you visualize very quickly the set of all 6 outcomes. You realize that there are 6 possibilities, and so you say 1/6. So that visualizing of all the outcomes, or actually the set of all the outcomes, we give it a special name. We call that the sample space. So the set of all the outcomes when you toss a die is 1, 2, 3, 4, 5, 6. That will be called the sample space. On the other hand, like if you toss a coin and you say, what's the probability of heads? Everybody will say 1/2. Why? Because they visualize the set of outcomes, the set of possible outcomes when you're tossing a coin. And those possible outcomes are heads and tails. So there's 2 of them. But anyway, you visualize that set for just a moment. And that would be called the sample space for tossing a coin, would be just heads and tails, the set containing heads and tails. Now, as I said, I'm not covering set theory here in these videos. Maybe I'll go back and do that, but it's important that you recognize here that I just used the word set, the set of possible outcomes. Okay, so here's the definition. The set of all possible outcomes of an experiment. Remember, experiment is very broad meaning here, so just any action that results in something with an uncertain outcome. So tossing a coin, you don't know what's going to happen. Rolling a die, you don't know what's going to happen. Flying to Mars, you don't know what's going to happen. Okay? Alright, so anyway, the set of all possible outcomes of an experiment. So rolling a die, the set would be 1, 2, 3, 4, 5, 6, is called the sample space for the experiment. The outcomes in the sample space are called the sample points. So the 1, the 2, the 3, the 4, the 5, the 6, when you roll a die, those are called the sample points. Okay, so here's another example of a sample space. This is for when you toss 2 coins. So the sample points and sample space of an experiment depend on what the experimenter chooses to observe. For example, if the experiment consists of tossing a coin twice, the experiment can record the sequence of heads and tails that result, in which case the sample space is this. So this means heads on the first and heads on the second. This means heads on the first and tails on the second. This means tails on the first and heads on the second, and so on. Okay, and we can use a tree diagram to sort of figure out what the sample space is going to be. So you just you just have a starting point here. You just write start with a dot there. And then you say, okay, for the first toss, what are the possibilities? You could get heads or tails. And then once you get heads here in the first toss, then you say, well, what can I get in the second toss? So it's also heads and tails. Or if I got tails, it would be heads and tails. And then you just follow one path out. And this one is HH, so we write HH. This one is HT, so we write HT, and so on. Now, we could also have an alternative sample space for the same experiment. If we only recorded not the sequence of heads and tails, but rather whether the two tosses... sorry, this is what... Sorry about that. On the other hand, the experimenter could record the total number of tails observed, in which case the sample space is different. So it depends on what we choose to kind of record. So here we're recording the sequence of heads and tails, but we also might choose to record just the total number of tails observed. So in that case, how many tails can you get when you toss two coins? Of course, you could get 0 tails, you could get 1 tail, or 2. So this would be the sample space if you choose to record like this. Or we could have a different sample space. Instead of choosing to record the sequence or the number of tails, we could choose to record whether the two tosses match or not, whether they're the same or not. So in that case, it's just whether they match or they don't match. So in that case, this would be the sample space. So the point is here that you could have different ways of constructing the sample space for basically the same action. It's sort of what you record, or what you, I'll say it's what you record. So here's an example again. Consider the experiment of tossing a die and recording the number on the top face. So we're just going to record what's on the top. There are 6 possible outcomes, or sample points, for this experiment. Thus the sample space is this. Right? Okay, second example. A light bulb manufacturer tests the bulb by letting it burn out, or letting it burn until it burns out. The manufacturer records the total time in hours that the bulb stays lit. So now we're recording how long it stayed lit. Since any non-negative real number may be recorded for t, so in other words, of course it's not going to be negative, it didn't stay lit for a negative time, but it can be anything 0 or greater. So we say that the sample space is this. This is what? This is the set of all values that are greater than or equal to 0. So that means any non-negative number. Okay, here's another example. A traffic engineer records the number of cars entering a tunnel. So you sit at the front of the tunnel, and between 9 a.m. and 10 a.m., and you just count how many cars are going into the tunnel. You might be interested in this. You might need this kind of information. So what's the sample space? What are the set of possible outcomes for the number of cars that go into the tunnel between 9 and 10? Well, maybe no cars go through between 9 and 10. Maybe 1 car goes through, and so on. Okay, so this is the sample space. But it's a little different than this sample space. This you could have like a half a minute, or half an hour, or a quarter of an hour, or whatever. whatever. But here, you can't have half a car. We're not really thinking that you could have half a car, or a quarter of a car. So it's just 1 car or 2 cars. So it's a little bit different answer. Okay, next, a stock market analyst observes General Electric common stock for 1 market day and records whether the stock increases in value, decreases in value, or undergoes no change. So, we could record the price. That's different. But here they're just saying, record whether it increases, decreases, or undergoes. So we have I, D, or N for the sample space. Okay? And the sample points are I, D, and N. Okay, another example. A geneticist records the sex of successive children in a 3-child family. So they're recording basically the sequence of gender. So in other words, you could have male first child, male second child, male third child, or male first, male second, female third, and so on. So this is the sample space, and it may be useful to use a tree diagram to figure it out. So then you would just put a dot here with start, and then you'd say the first child, what are the possibilities? So you list the possibilities here. So the possibilities are male and female. And then the second child, what are the possibilities given that the first child is male? Well, it's still M and F, and same thing here, M and F, and M and F, and so on. So if we follow any branch out, we get one element in the sample space, or we get one sample point. So MMM is 1, another one is MMF, and so on. And there are 8 of them here. 2 times 2 times 2. There are 8 of them. Okay, one more example. Horses A, B, and C are running in a race, and the winning horse is recorded. Assuming that there are no ties, the sample space of possible winners is either A wins. We're only recording who won. So either A wins, or B wins, or C wins. So the sample space is A, B, C. Those are the possible outcomes of this experiment recording who wins. Okay, so these are examples of sample spaces.